Okay, good morning. So this time, today we're looking at quadratic equations and inequalities. We're looking at the examples for exercise 2.13. When I've done this lesson with the class, we were experiencing load shedding at the time again. So I'm just going to record this lesson now. Alright. So basically we're looking at quadratic equations, the examples for exercise 2.13. And the exercise 2.13 is on page 45. Okay. So at this point, we've discussed the table in 2.12, and we came up with this summary. If the discriminant, now the discriminant is the expression b squared minus 4ac. The expression b squared minus 4ac is called the discriminant and is written as delta, or that triangle, is equal to b squared minus 4ac. If a, b, and c are rational numbers, then delta determines the nature of the roots of the quadratic equation. Okay. So we are told that if delta is less than 0, which means to say delta is negative, as you can see in yesterday's example, or the lesson before's example. If delta is negative, the roots are non-real. If delta is equal to 0, as in this case here, the roots are real, rational, and equal. You see, these three last columns explains how the nature of that root would be. Okay. In this case, real, rational, and equal. If delta is greater than 0, a perfect square. Perfect squares are 1. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 over 4, which is 3 over 2. All of those, as long as the square root can be taken, okay, it will be known as a perfect square. Then the roots are real, rational, and unequal. However, if delta is greater than 0 and a non-perfect square, then the roots are real, irrational, because that's a third, and unequal. So the only time the roots are equal is if delta is equal to 0. Okay? If it's a real, if they say only roots are real, then there it is real, there, and there. So absolutely, and there. So sometimes it's just forgotten or overlooked. If it's a real, the roots are real, it's real, real, real. So you say for real roots, and delta is greater and equal to 0. Okay, that's the condition. Okay, so let's carry on. So we're looking at example 1, and example 1 is on page 44. Example 1 on page 44. Let's take us up here. So in each of the following equations, calculate delta, which is b squared minus 4ac, and then determine the nature of the roots of the quadratic equation. So remember, we're not going to solve the equation. Okay, we're only going to work out the value of the expression delta. So we started by saying delta is equal to b squared minus 4ac. Again, to extract your a, b, and c from the formula, or from the equation, it must be in the form of ax squared plus bx plus c, which is also known as standard form. So it's negative 3 squared minus 4 times 2 times 2, which gives you 9 minus 16, which is negative 7. So what can we say about this nature of this roots here? So since delta is less than 0, so what can we say about this? Therefore roots are non-real. When something non-real, if it's under the square root, is negative. Okay. Let's look at number 2. This is still part of example 1. There's a second of its examples here. Look at number 2. You are given 2x squared minus 3x minus 2 is equal to 0. Again, what is delta? B squared minus 4ac. What is b? Negative 3, so it's negative 3 squared minus 4. A is 2, c is negative 2, which gives you 9, plus 16, which is 20. So what do you notice here? Delta is a perfect, delta is greater than 0, and it's a perfect square. I don't have to write this, okay? So what would the nature of this root be? Remember, if it was a perfect square and greater than 0, we said greater than 0, it's a perfect square. We tell that the roots are real. Roots are real, rational, and unequal. Only time roots are equal if it's equal to 0. Let's look at the third one. Number 3. We got 2x squared minus 3x minus 1 is equal to 0. Okay? So again, what's delta? It's b squared minus 4ac. I always start off like that. So it's going to be negative 3 squared minus 4. A is 2, c is negative 1. Which is 9 plus 8, which is 17. As you can see, a delta is greater than 0 and a non-perfect square. Alright, so is the roots real? Yes, it's real. It's irrational because it's a surd now, and it's unequal. Okay. It's just always coming back to this somebody that was made with regards to delta. Okay. Let's carry on. This is example 2 now. And example 2 is on page 44 as well. Now we are to consider the quadratic equation x squared minus 4x minus plus k equals 0. So what's the difference now between example 1 and example 2? Is that now we got the variable in terms of a constant. Okay. It says calculate delta, which is b squared minus 4ac. The delta is equal to b squared minus 4ac. In terms of k. So what is your a value here? A value is the coefficient of x squared, which is 1. B is the coefficient of x, which is negative 4. And c is equal to
My apologies for the interruption.
Okay.
All grade 9 is going on the excursion.
So
Can you please move towards the science exit?
C.
All grade 9 is going on the excursion to move towards the science exit. Thank you.
Okay. So that is your delta in terms of k. Then, and remember, I'm not going to take anything over the equal sign to say is delta. Okay? So we're not going to solve for k. However, in number 2, we are told determine the value of k if the roots of the quadratic equation is real. So under what condition would it be real? It will be real if delta is greater than 0, non-perfect square, greater than 0, perfect square, and will be real if delta is equal to 0. So I say here, for real roots, what can I say? Delta is greater than or equal to 0. Okay? For real roots, delta is greater than or equal to 0. We have worked out delta to be 16 minus 4k, of course, will be greater than or equal to 0. So negative 4k is greater or equal to negative 16. Divide by negative, the inequality swap around. 16 over 4 is going to be. So if you choose any value for k that is less than or equal to 4, the roots will always be real. Okay. So with that, you should be able to do exercise 2.13 on page 45.